Hello everyone, we have a new circuit here. This is a 4026 decade counter. So let us see the circuit here. This is the 4026 IC. This is a decade counter. 7 segment LED display, red. Only a single digit. I'm using only a single digit. Some resistors, ceramic capacitor, resistor, header, push button, and an LED. Pushing the button. So this is a decade counter capable of counting from 0 to 9. That's why it's called decade counter, from 0 to 9. This is a increment button. And this one, this is a reset button. So the number is 7. We're going to reset it. It goes back to 0. Again, increment button. 8. Reset counter, push button, 0. Increment, reset, set, reset. That is the purpose of the push button there. Also, we have this. This is our previous circuit, and there's also a 4026 IC, LED, some resistors, capacitor, and a push button switch. So this is also a decade counter, capable of counting 0 to 9. These two are connected to a voltage supply. Also, we have this one. This is an automatic counter. Did you see that? There's also 4026, an LED 7-segment display. Color, it's I think it's yellow. And the IC, it is 555 timer with some resistor, capacitor, and this is an automatic counter. Unlike this one, these two, this is a manual counter, counting from 0 to 9. And this one, the difference with this is it has a reset button. Here we don't have a reset button because this is our previous circuit. But here we have an automatic up counter, counting from 0 to 9. All of these three circuits are using 4026 IC. The difference of the two manual counter is this one has no reset button, only an increment button from 0 to 9. And this one, we have a reset button. Aside from the reset button, we have this, a standby power on LED indicator. It means that there's a current in the circuit. Unlike here, we have no lights here, no LED. Here, this is also our previous circuit. And you see the LED here, that is the clock, providing a clock pulse to the LED, and it counts automatically because of the 555 timer that serves as the clock pulse, making it as an automatic counter. It counts from 0 to 9 because of this 555 timer. it is automatically counting the number from 0 to 9. Unlike this one and this one, these two are manual counter. The clock is provided by this push button. Okay. Let us see the circuit diagram of the circuit. This is a 4026 up counter manual with reset. We have the 5-volt supply. So in this our new circuit, we have this 5-volt supply. And we have this switch. The switch of the voltage supply. Also here in the circuit diagram of our new circuit, we have this. A resistor in series with the LED. The purpose of the resistor here is to limit the current flows in the LED. So this is a LED standby power on indicator. In order to know the presence of the circuit, or it means that the circuit is on. Upon closing the switch, we have this power on standby indicator. This one, the yellow one, no, the green one. Upon closing the switch, did you see that? The circuit is off when you close the switch or power on the circuit. Then we have this, like a green LED, 3mm in size. So when you close the switch here, current flows into the positive, to the switch, to the resistor, and to the LED, making the LED lights. We're going to compute for the value of the resistor to limit the current flows by using KBL. So when we have this switch 0 is closed, we're using KBL, Kirchhoff's voltage law. The sum of all voltages in a loop is equal to 0. Voltage supply minus the voltage drop across the resistor, and then to the diode, to LED, is equal to 0. Voltage supply minus the voltage drop across the resistor RD1 minus the voltage drop across the LED is equal to 0. Transposition and substitution. 5-volt supply, 2 volts. 2 volts is the voltage rating of the LED to turn on. This is a standard value. You can find this in the data sheet of the LED. Calculation, we got 3 volts. So the voltage drop across this RD1 is 3 volts. So upon closing the switch, current flows here, making a first KBL, and we now know that the voltage drop across the resistor here is 3 volts. So the LED is lighting on here, turning on. Since we know the voltage drop across the resistor using the Ohm's law. Voltage is equal to current times resistance, transposition, substitution, calculation. Voltage drop across the resistor is 3 volts. And the current rating, or the current flowing into the resistor, is 0.02 ampere, also given in the datasheet of the LED. The current flows here is 0.02 ampere, given in the datasheet of the LED. So we get now 150 ohms, but I use 220 ohms, my available resistor, and it is okay. As you have seen here, the LED is okay. It's turning on. Again, when you close the switch, current flows also here into the RS. What is this RS? This is a pull-up resistor. And to the switch up to this point, because the switch here, push button switch, is still open, normally open switch, current flows only up to here, this point. Current flows here to the pull-up resistor. What is the purpose of this pull-up resistor? To provide a continuous current flows to the IC. And we also have this, a coupling resistor with the switch and the resistor, RC. This is an RC circuit. Since when you close the switch, current flows to the RS. Pull-up resistor provides continuous current flows here to the circuit, to the IC. Also current flows here to the RC. RC is used to debounce, or to couple the circuit to debounce the switching, because we're going to push the button here to produce a stable voltage, stable current here. We need this coupling resistor, and this one is the capacitor. So current flows here directly to the IC, also flows here when you close the switch. So current flows here at the LED, standby power on, and into the pull-up resistor, coupling resistor, and this debound circuit, RC circuit, also flows here directly to the IC and to the capacitor, charging the capacitor. We have the value of the capacitor, 104. This is a ceramic capacitor here, this small one. And the value of the RS here is arbitrary, or I choose the value 100 kilo ohms, and I choose the value 50 kilo ohms for the RC, just to limit the current flows, or to make an input signal here. Whenever we are going to trigger a pulse here, we're going to limit the current flows here. And to the datasheet of this IC, which is 4026, we need at least plus or minus milliampere of current to flow in this pin 1. So I'm using this 100 kilo ohms, 50 kilo ohms. Every time you close the switch here, current flows here, and we're going to compute for the value of the current flows here up to the IC. Using Ohm's law, voltage supply is equal to current total and RT. RT here is the sum of the two resistors in series, the sum of the two. So we got 150 kilo ohms, and the voltage supply here is 5 volts. By substitution, transposition, substitution, we know that voltage supply, voltage total, the same. Also the total resistance here, the sum of the two, 100K and 50K, we got 150,000 ohms, or 150 kilo ohms. calculation, we got 0.00033 ampere. That is the current flows into the IC pin 1, to the pin 1 clock, pin 1, upon closing the switch. At the same time, when you close the switch here, the current flows here in the capacitor, charging the capacitor. So we can compute the charging and the discharging of the capacitor by using the time constant. You see this? Tau. But since we're not still using push button here, we're going to first see the current flows also into this node. When you close the switch into this line, pin 3. Pin 3 is DEA. This IC is the 4026 IC now, and we got 16 pin out here, or 16. 1, 2, 3, 4, 5, 7, 8, up to 16. And for the pin 3, we got this DEI, display enable input. The purpose of this is to provide a voltage supply, power supply to our LED 7 segment. So it's providing a power supply here. This is the current source of this. So making the LED 7 segment to turn on, making it high. Because current flows here into the input of the display, flows to the output. We have several output here, 6, 7, 9, 10, 11, 12, 13 output, all connected to our 7 segment LED with its corresponding pin out. And to complete the circuit, we got this. We ground this with a resistor here to the ground. Pin 8 here is the ground. So the current also flows here to the IC and out to the LED, because this IC is serving as a driver, a display driver for this LED segment. Out, in to the pin out, and then out to the ground with the help of this resistor. So again, closing the switch, current flows also up to here. Since the push button here, the reset button is open up to this end only. Again, current flows here into this pin number 16. Number 16, BDD. BDD, that is the supply source, or the source supply of the IC. Power supply source of the IC, powering this 4026. So this one, supply of the 4026. This one, the supply of the display LED. So we now know all the current that flows when the switch is closed. Okay. When you push the button here, still there's nothing happen here. When you release the button, it increments. Push the button, release, it increments. When you push the button, forcing the current to flow into the ground. There's no current flows here when you push the button. When you release the button, again the current flows here, up to the pin 1. This is a clock. we're using this push button to provide a clock pulse. Since we're using a manual 4026 as a manual counter. Unlike this one, this is an automatic counter because the LED is counting automatically with the help of this 555 timer. So let us see the circuit diagram of this previous circuit. This is our previous circuit, 4026 manual counter, and much as the same design with our new circuit here. A little bit rugged in design. The only difference is it has no reset button. No reset button in the pin number 15. Pin number 15 here is only grounded. But here we have the reset button. That is the reset button to the pin 15, and it is grounded with the help of this 10 kilo ohms. I'm using this value. This is arbitrary value just to reset the counter. So as I've said, this is our previous circuit. This is small one. This is the schematic diagram. It has no reset button. The reset button is just grounded. Unlike with the new one, it has a reset button and with the help of the resistor to the ground, making to clear the value of the LED to go back to 0. Unlike this one, this is an automatic counter with the help of the 555 timer. So let us see the circuit diagram. This is our previous circuit, 4026 555 timer counter 0 to 9. This is the 555 timer. And this one is the 4026, and this is LED. Very messy, rugged design because this is previous circuit. As you have seen here, the pin 1, the clock pin of the 4026 is connected into the output of the 555 timer. So it is providing a clock pulse to the clock pin 1 of the 4026 IC. Unlike the manual, the clock pulse is provided by triggering a pulse using push button here. Also, with our new circuit, the clock pulse, we are producing a manual clock here by producing or triggering a pulse using push button here, switch, that will serve as a clock manually. So we now know that this is automatic counter by using 555 timer. It automatically counts from 0 to 9. These two difference, it has reset button, no reset button. This is a previous circuit, this is our new circuit. So again, we have now come into the stage of pushing the button. Nothing happens when you release, and the counter is incrementing into 1. Releasing the button here, making the resistor to capacitor to discharge and discharging through here. When you release it, current flows it, charging the capacitor, and then when you push the button, capacitor discharging it through here. When you release it again, capacitor is discharging, and this serves as a voltage stabilizer. This is the circuit. Or sometimes they call it a debouncing circuit, or sometimes they call it a high pass filter. But for this circuit, I'm using this D-bound circuit, RC. These two, R and C, 104. Value of RC is 50 kilo ohms. I choose this 50 kilo ohms and 104. We can compute for the discharging effect of the capacitor charging and discharging using the time constant. How fast is the charging? When you push the button here, current flows here, here. Shorting the circuit, push the button, shorting the circuit, and then when you release the button, the current flows here into the IC, charging the capacitor. When you push the button here, discharging the capacitor to the ground, releasing the button, charging, pushing the button, make it short, discharging the capacitor here, releasing the button, current flows here, charging again the capacitor. So this is a voltage stabilizer, sometimes called it switch debouncing. So let us see the discharging effect, how fast it will discharge and charge using this formula, tau, the symbol tau. When you release the button, tau is time constant, resistance times the capacitance. In order to know the charging and discharging speed of the circuit, R is 50 kilo ohms and then RC is 104. 104 is the ceramic capacitor here. You can see it in the capacitor 104. But this 104 is also equal to 100 nanofarad. Just substitute the 4 into 0 and N, making it nanofarad. That is the value of the capacitor. 50 kilo ohms, 50,000 ohms, the same. Nanofarad is also the same as 100 times 10 to the negative 9 farad, negative 9. Or when you transposing the 0 to the left, making it 0.1, making it a microfarad. Or microfarad is also equal to negative 6. 0.00 or 0.1 times 10 to the negative 6. Because we're going to transposing it to the left by 3, making it 0.1, negative 6. Or is equal to 0.000001 farad. 0.0001 farad. By calculation, we got now the speed of the circuit, 0.005 seconds. That is the speed of charging and discharging of the capacitor here. Very fast. To make a clock pulse here, we need to trigger the pulse here, providing a high level or input level here. Since we now know how to provide a clock pulse manually by using this triggering pulse or this push button, we have also in the port 326 pin 2, which is the clock inhibit. It is grounded, or it is in a low level or 0. It will make the circuit to increment. Every time you push the button here, it will increment the value of the LED into 1, 2, 3, 4, 5, 6 if you grounded this pin 2. Pin 3 here, as we have already know, this is the power source of this LED. Pin 4 DEO is used when we are using 2 digits. So we have no connection here. 5 also is carry out CO for the 2 digit also. Since we're using a single, we're not using this pin. Pin 6 here is the output of the IC. So the output here is connected into F, tracing the line pink into F. So let us see the LED here. the input here is connected to the output of the 4026. The pin out of this LED common cathode. This is common cathode LED 7 segment display. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is a pin out. And this one, we already know that this is a segment. This red line serves as a segment. Here, every time we're going to activate this segment, this is segment A. This is A, located in the pin number 7. Segment A, B, C, D, E, F, G. So, since pin number 6 of the IC is located at F, so we're going to activate the F here, F segment, to the pin. Since this is F, F here is A, B, C, D, E, F. Activate this F. For the 7, G, activating this G depends on the input. Also, this one, 9 is connected to D. The blue connected to D. C, D, or the pin 2 of the LED. The output, same, A10, E11, 12B, C13. C13 is connected to C. Pin 13 is connected to the C or to the pin number 4 of the LED. So we now know that this is the output of the IC connected to the input of the LED segment. And the input here is, in order to complete the circuit, we're going to ground. This is a common cathode, so we use this resistor. Also here we have this ungated C segment. It is also used when we're going to use a 2 digits LED display. So we have no connection here. And 15 is the master reset. We have this reset button here. Reset button. It reset or force the circuit to a low level, forcing it to make it go back to zero state or zero value. Every time you reset, the circuit clears the IC. So when we have this value here, 6, we're going to push the reset button. It goes back to 0 because the current flows here directly to the ground, making it to clear all the input values of this LED, making it 0. This reset button, I use 10 kilo ohms. Well, this is arbitrary. I select this 10 kilo ohms to couple C2 to pull down, that will serve as pull down resistor to the ground, making a closed circuit here. Or you can use a value of 1 kilo ohms or 100 kilo ohms or 10 kilo ohms. Just to pull down the resistor to clear the circuit to reset the IC into 0. So what's here? That is the voltage rating of the LED, and the input current, as we all know, plus or minus 10 milliampere. That is the requirement for the clock here, 10 milliampere. Also, we computed the value of the resistor, grounding resistor here by, since we close the circuit here, current flows here to the display, powering the circuit out, and then to the display, to the ground by using the resistor, using KVL, voltage supply minus the voltage graph across R1, and then this 7 segment. See, there is also a voltage drop across the 7 segment. Powering on, current flows here to the IC and then goes out. So there's a resistance here of 2 volts, standard or typical value of LED. our voltage drop here and the voltage drop here, R1. Since we are going to know the voltage of R1 by transposition, 2 volts, the voltage drop across this LED, voltage supply, calculation, we got 3 volts. So I'm using now 3 volts, that is the voltage drop of this R1, the grounding resistor for this common cathode. Transposition calculation, we got 150 ohms and I'm using 220 ohms for this resistor. To complete the circuit, on to the IC, out, then in to the LED, out again to the resistor, to the ground, completing the circuit. So we have now this. Reset. Here we have no reset here, it is just an up counter manual. Here we have automatic counter using 555 as providing the clock. Here manual. Since we know the current flows into the circuit, we have now this. "4026 up counter manual with reset." This is a simplified circuit diagram. See, the ground is this. And I'm using this header. This one, the header. So, this header. This is the Pcb Layout. We have the LED here, the 2 push button, the same. Resistor, ceramics, resistor, 4026, the header. For the header here, connected it to the circuit. This is the simplified block diagram, or I mean the circuit diagram, just to simplify the circuit. See? The IC connected to the LED driver, grounding resistor, means the A here, that is the input A connected to the pin 10 of this IC to the A. The A here, see it? Let us see that again, the A. Okay. A here is this. A is pin number 10 of the IC. This is the actual IC connection. A10, pin 10 to the A, since A, we know A here is this, A, B, C, D, E, F, G, so A here, then A, B, 12, this we are not using this because as I've said, we're using only 1 digit, so this is, it has no connection. This have no connection, these 3 pins here. The CO, the EO, and then UCS, ungated C segment. The display enable output, carry out, is only used for 2 digits LED. Grounded here is the 8, pin 2 inhibit, the clock, as you have seen here. We have a provision, since this is a new features here. We have a reset button for the new circuit, standby LED. That is the new features of the circuit. And the header for power supply. So the header here is connected to the power supply. See the header here, plus, minus, power supply. Also, we can also connect it in here, so we can provide an additional power supply here. And in the center we have this. This is a clock. This is a provision for input. We can connect a clock here. Aside from the manual counter using the push button, we can also connect a 555 timer or any clock pulse to make it an automatic counter. This is only a provision, or you can use this in the future. This is the actual PCB layout. I'm using this, the same as this actual circuit here, same drawing. You see here, grounded, the ceramics, the switch 1, the increment button, the reset button. This is simplified circuit diagram, just to simplify the circuit. And we have the parts here. We have this 4026, 220 ohms times 2. We have 220 here, 220 also here, 100 kilo ohms, 50 ohms, also 7 segment display, header, push button, 2 LED 3mm green, and perf board and some jump wires. This is the perf board and some jump wires. That is the jump wires. So very complicated. Just like this old previous circuit. This is a manual counter, automatic counter, and that is the end of the discussion here. This is circuit diagram, simplified, the PCB layout. So this one is the R1, RD1, R1, RD1. Where is the R1 here? Somewhere here. This is the R1, RD1, some RS, RC, RO, RS, RC, RS, RO, RO, LED display segment, push button, and this is the header. That is the PCB layout, the simplified block diagram. The current flows here. This we discussed already. So that is the basic operation of up counter 4026 up counter manual with reset button. Okay. Thank you for watching the video. Bye.